In today's lesson, we're going to have a look at circular functions, and in specific, we're going to have a look at some basics related to circular functions. And the first part of it is basically converting the unit of an angle from degrees to radians. So far, anytime we've dealt with angles, we've always dealt with it in the form of a degree. With the introduction of trigonometric functions, or in the need to sketch sine or cos or tan functions, we need to look at another unit for angle, which is called radians. Now the relationship between the two is that 1 radian, which is given by the symbol pi, is equal to 180 degrees. And the quickest way to convert between the two units can be done by the form of a flow chart. So I'm just going to quickly draw up a flow chart for the conversion. So if I'm converting from a degree to radians, all I have to do is multiply by my question by pi over 180. On the other hand, if I'm converting from radians to degrees, I've got to multiply my question by 180 over pi. Let's have a look at a couple of examples for the conversion. So if I take 120 degrees, for example, and I want to convert this degree in the form of a radian. So I'm going to start by multiplying the question by pi over 180. Now the common factor between 120 and 180 is 60. Now 60 goes into 120 2 times, 60 goes into 180 3 times. So the 120 degrees has now been converted in the form of radians to 2 pi over 3. On the other hand, if I take an example of radians, so let's take 3 pi over 5, and I want to convert this value in the form of a degree. So we're going to start by multiplying the question by 180 divided by pi. Now pi goes into each other once, and 5 goes into 180 36 times. And so if I complete my multiplication, so 3 times 36 gives me 108 degrees. And that's how you convert between the two units for an angle. Now the second part basically consists of the introduction of the unit circle. Now unit circle is very significant for the understanding of circular functions and how we're going to sketch sine, cos and tan functions. So to start with, let's talk about the unit circle. The unit circle basically is a circle which has a radius of 1 unit, right? And its center is located at the origin of a Cartesian plane. Now, in the diagram given to us below, we have an example of a Cartesian plane, and as you can see, the center of that circle is at the origin of the Cartesian plane. Now, some basics: when we draw a Cartesian plane, we split it into 4 quadrants. Quadrant 1, 2, 3, and 4. Now I'm going to start by marking some angles in this unit circle. So we're going to start with the 0 degree angle there, and then the top gives us 90 degrees, 180 degrees, 270 degrees, and then 1 complete revolution gives us 360 degrees. Now the same values in the form of radians can be written down as 0 radians. 90 degrees is basically pi over 2 radians. 180 degrees is pi radians. 270, 3 pi over 2, and then 1 complete revolution is 2 times pi radians. So understanding of the radians along with the degrees is a significant part of the unit circle. Now with that behind us, let's move on to this particular diagram here. Now in this diagram, what we've done is we've basically taken a point P on the circumference of the unit circle. Now point P has been given coordinates x and y. Now where x is basically the horizontal distance and y is basically the vertical distance. And what we've also done is we've basically completed a right angle triangle in this particular scenario. Now if I apply my basic trigonometric ratios, and by that I mean sine, cos and tan, which we can easily remember by the use of SOHCAHTOA TOA, if we can apply my three trigonometric ratios to this particular triangle, ONP, I can see that sine theta is equal to the opposite over hypotenuse, in this case which is going to be y divided by 1, or in other words, sine theta basically is equal to y coordinate of the point P. Similarly, if I apply the cos ratio, cos theta is equal to adjacent over hypotenuse, which in this case is going to be equal to x over 1, and in conclusion I can see cos theta is equal to the x coordinate of that point P. Now tan theta, there's a couple of ways we can find tan theta. We can simply go opposite over adjacent, or we can also use tan theta is equal to sine theta divided by cos theta. Now we've just figured out that sine theta is equal to the y coordinate of point P, and cos theta is equal to the x coordinate of point P. So what we can conclude here is tan theta is equal to y divided by x, in other words. Now there's a couple of other things I want to point out in this particular case. I'm just going to quickly write down my angles again. So 0 degrees, 360, 90, 180 degrees, 270 degrees, and again I'm going to write it in the form of radians as well. So I'm going to have 0 radians, 2 pi radians, now pi over 2, pi, and 3 pi over 2. Now given that we've just understood the fact that sine theta is basically the y coordinate of the point, and cos theta is equal to the x coordinate of the point, and tan theta is basically equal to y divided by x. Now with that information, we're going to basically figure out the values of sine, cos, and tan on all the different axes of the unit circle. So we'll start by the 0 degree angle. Now if I take the 0 degree angle, or 0 radians, the value for sine theta, or sine 0, is basically equal to the y coordinate at that point, which in this case is equal to 0. So I can conclude sine 0 is equal to 0. Similarly, cos 0, cos is the x coordinate, which is going to be equal to 1, and tan theta is basically equal to sine divided by cos, in this case 0 divided by 1, which is going to be equal to 0. Now if I take the second point, which is at 90 degree angles, the coordinate of that point is going to be 0, 1. Similarly, if I take the 90 degree angle, or pi over 2, I can see that sine 90 is going to be equal to the y coordinate, which in this case is going to be equal to 1. Cos 90 is the x coordinate, so that's going to be equal to 0. Now tan 90, so tan 90 is going to be equal to 1 divided by 0, and any number divided by 0 is basically undefined. Right? Similarly, we can go ahead and figure out the values for sine and cos on the other 2 points as well. So at 180 degrees, the coordinates are going to be -1, 0. At 270 degrees, the coordinates are going to be 0 and -1. Now let's have a look at a couple of examples. Now the question says evaluate each of the following. So sine 3 pi on 2. So sine 3 pi on 2 is basically this particular point here. That's the value when the angle is equal to 3 pi on 2. And sine refers to the y coordinate. So the y coordinate of that point is equal to -1. Therefore the answer to this question is going to be equal to -1. Now the other aspect here is sine of -3 pi on 2. Now there's another important factor before we get into that question. Right? Now angles are always measured positive in the anti-clockwise direction. So if we go in the anti-clockwise direction, the angles are measured positive. Similarly, if we go in the clockwise direction, the angles are measured with a negative sign in front of it. Alright, so angles are measured positive in the anti-clockwise direction, and angles are measured negatively in the clockwise direction. So if we take the second question into account, which is sine of minus 3 pi on 2, so minus 3 pi on 2 is 270 degrees. So if I continue my unit circle in the negative direction, what I do is I end up at this particular point here. Right? And again, sine is basically the y coordinate of that point. So therefore, sine of minus 3 pi on 2 is going to be equal to a positive 1. Now this next question here is cos of 23 pi on 2. So obviously 23 pi on 2 is greater than 2 pi. So the way I deal with this question is basically I figure out how many times 2 goes into 23. So 2 goes into 23 11 times. So 11 pi with the remainder of 1 pi, so plus pi on 2. Right, now I'm going to go back to my unit circle. Alright, so we have 0 degrees on the right hand side, or 0 pi, and then we complete to 1 pi, and then 1 revolution takes us to 2 pi. Now what I can see from here is my 11 pi is going to be at the same position as 1 pi. Now we're going to add pi on 2, so pi on 2 takes us to this particular point here. So if I take it to this particular point, the question here is saying, what is the value of cos 23 pi on 2? And cos is basically the x coordinate of that point, which in this case is equal to 0. So let's go back to the question. Cos 23 pi on 2 is going to be equal to 0. Now the last one here, tan 55 pi. Now again, you know, when it comes to odd numbers and even numbers, in terms of the pi, the odd numbers on the left hand side and even numbers on the right hand side. So 55 pi is basically going to be at this particular value, and tan is equal to y divided by x. In this case the y coordinate is 0, the x coordinate is minus 1, so which is going to be 0 divided by minus 1, which is also going to be equal to 0. Right? Now the basic conclusion of values greater than 2 pi is given by these 3 points here. Now we know sine and cos functions have a period of 2 pi, and a tan function has a period of pi radians. So what it means by here, what these statements referring to, is every time you do a 2 pi rotation on the unit circle, you get back to the same value for sine. And every time you do a 2 pi rotation for cos, you get to the same value for cos. And for tan ratios, because the period is equal to pi, every time you do a pi rotation, you get back to the same value. Alright, so that's what these 3 statements are referring to. We're going to continue the rest of the lesson in the second part of this video. So thank you for watching.